Okay, quick review of Unit 2, Day 4, our introduction to rational functions and their key features. Rational function, when we think rational, we think fraction, which is exactly what we have here. We have a polynomial divided by another polynomial. And when you end up dividing two polynomials, it ends up being hard to intuit what the graph is going to look like. It's hard to picture the graph because we're taking the outputs of this polynomial and we're dividing it by the outputs of this polynomial. There's a couple of issues that can show up graphically, and it's also just really hard to picture what's going to happen to this graph in the long term, which means it's hard to think of its shape. So we started to deconstruct it today by looking at a couple of key features that can show up. Holes versus vertical asymptotes. Starting with holes, when we look at this, we're tempted to say, well, x minus 2 on top, x minus 2 on bottom, we can cancel that. Which we can, because no matter what we plug into this, like let's say we're plugging in 7, we get 7 minus 2 divided by 7 minus 2, which is just going to be 5 over 5. So overall, we get 7 minus 2 times 7 minus 5 divided by 7 minus 2, which is just going to be equal to 2. So it turns out that these two factors have nothing to do with the output. It's really only this factor that's determining the output, because these two are canceling each other out every time. The one issue is that x equals 2. If we were to plug in x equals 2, we would get 0 divided by 0, which is an undefined value. So we say there's a hole at x equals 2. Now, what's the y value? Well, again, the shape of the graph is not determined by these factors, it's determined by him. So all we have to do is plug 2 in to x minus 5, and 2 minus 5 is negative 3. So we have a hole on this graph at 2 minus 3. So what it's going to look like is it's going to be a line, the line x minus 5, but then when you hit the point 2, at x equals 2, there's going to be a hole there at 2 negative 3. Now, vertical asymptotes are a little bit different. In class today, what we talked about was what happens when you divide a non-zero number by a number close to 0. So we talked about this example of dividing up a cookie between all of your friends. So let's say we plug in something like 2.001 to this other function over here. So we say we have 1 divided by 2.001 minus 2. Well, that's just going to be 1 divided by 0.001. So this is our one cookie. This is our one cookie up here, and then we're going to give everybody 0.001 of that cookie. Well, how many people can we share with? A lot. We have a lot of people basically getting no cookie, right? And the smaller that quantity gets, the more people we can share with. So if you think about 1 divided by 0.000000001, that's going to be really big, and the smaller the number gets, the closer we're going to get to infinity. We're just going to keep getting bigger and bigger and bigger. And that's what's happening at asymptotes. We're going to discuss more what that looks like graphically, and you can also check that out in the concept breakdown. So we have a vertical asymptote then at x equals 2 in this case, instead of a hole, because it's only on bottom. So then we can go down to an example like this one, and we can say, okay, I know I have a hole at x equals negative 4. Okay, here's my hole. Now, what's the y value of that? Well, again, these factors are not affecting the shape of our graph, right? They're just causing the hole at negative 4. So to figure out where the hole actually is, we're just going to plug in negative 4 to our other factors. So what do we get? Let's see. We get negative 4 plus 1 is negative 3 in the numerator. Negative 4 plus 6 is just 2 in the denominator. So we have our hole at negative 4 comma negative 3 over 2, which is negative 4 comma negative 1.5. So that's where our hole is. We have vertical asymptotes. Okay, what's going to make us, let's go back. What's going to make us divide by basically 0? Well, that's when we plug in negative 6, something close to negative 6. So we have a vertical asymptote at negative 6. As we get closer to negative 6, this function is either going to shoot to infinity or shoot to negative infinity. Okay? And then last thing, still kind of a confusing thing for a lot of people, is the X Intercept. And that is what makes the function itself equal to 0. So if we plug in negative 1, right, we get 0 on top, we get something non-zero on bottom. That's okay, that's good, that's a real value, it's equal to 0. So then the last thing we did is we actually wrote the domain of a function like this. So we said, well, we have to exclude the x values of the vertical asymptotes and the holes. So we say negative infinity until we hit negative 6. And then we can go negative 6 until we hit negative 4 where we have a hole. And then we're going to go negative 4 to infinity. I can just barely fit it on. So negative 4 to infinity. That's our domain. Our function has vertical asymptote at negative 6 as a whole at negative 4 comma negative 3 halves, and it has an x-intercept at negative 1, 0, which means we're going to cross the x-axis here. And then our next goal is to figure out how can we actually sketch this and get a pretty good idea of what the behavior of the graph overall. And that's kind of our next step. Good class today, everybody, and I'll see you next week.